Okay, so we're live. Hello and welcome to this webinar called Code Smarter AWS AI Tools for Modern Development. My name is Tobias. I'm a technical sales engineer and AWS consultant at Copebit, an advanced AWS consulting partner in Switzerland. And besides that, I'm an AWS community builder in the DevTools realm, and I live in Zurich. I am joined today by Ramon Lopez, a senior solutions architect from AWS, who has built microservices for more than 150 million Amazon Prime users. So he's very knowledgeable about DevOps and scalable systems and microservices. As the title implies, we are going to talk about AI tools today. And I'm sure all of you have gotten in touch with AI tools before, be it Claude or ChatGPT or even MSNQ. There is a lot of movement in that area. And today, Ramon and I are going to present you two tools and multiple concepts that we think are worth sharing for developers, DevOps engineers, POs and PMs alike. We'll start with a short presentation about MSNQ and Hero, and then we'll showcase 3 demos. The first one will be about spec-based development, the second one about generating diagrams using MCP service, and the third one debugging ECS tasks using an MCP server as well. If you have any questions, please write them in the chat, and if we have time, we'll try to answer as many of them as possible in the end. So first, for the presentation, I hand over to Ramon, and please take it away.
Thank you, Tobias, and hi, everybody. I'm going to share my screen right away. So a quick intro about the topic today. The topic is, as Tobias said, GenAI-assisted software development, and I want to talk a little bit about our approach when it comes to these coding assistants and why it's not only about coding, right? What we know from our own experience building AWS, building Amazon, and many of those businesses, our SDEs, our software developers, they spend a considerable amount of time not coding, right? Not to say that this is a bad thing per se, but you want to focus that time that you are coding as an SDE on the task at hand. So we want to really reduce distractions so that this 1 hour or maybe even less per day can be spent in kind of flow state, in a very focused, in a very concentrated way. So what happens in reality, right? You have, as a developer, you have various meetings scattered throughout the day. You talk to other developers, of course, you do code reviews, you do a lot of operations, especially in DevOps mode. Teams, modern software teams do a lot of operations. And so that time that you do code is quite reduced. If we look at this as a circle, as a kind of beginning and end, there's an exploration phase at the very beginning of your let's say journey to build a new application or to build a new system or a new feature. There's exploration, there's planning. Then there's the actual coding phase, the creation, creation of assets. Then of course there's testing and securing. So this is where you harden those systems, you validate them, you improve resilience and all of these steps. Then there's a deployment part, and at the very end, in reality, we don't just ship new features. We also have to maintain and we have to modernize, right? So that can be Java updates, that can be .NET migrations to, let's say, Linux, for example. So lots of tasks that need to happen, that need to go into your sprint budget, let's say, that are not necessarily creating new value for your business. So Q Developer was really built around this idea of reducing distractions for developers and giving them almost like a peer developer at their disposal, right? You want a Q developer to be an expert not only in the coding aspects, but also in these areas like testing, deploying to AWS, and helping modernizing and upgrading systems. So Q is this assistant that is not only, as I mentioned, in your IDE, and it's also not only meant to be for the very typical software developer. Actually, in my own experience working with customers now over the last year or two with Q Developer, we see more and more roles, could be data engineering, can be on the operation side of things, people working with infrastructure as code, people working with Terraform. These roles benefit from Q Developer as well because they do all of these things, right? They do code from time to time. They do spend time in AWS console, and they do use AI assistants throughout their day. So the idea is that, for example, in the exploration, the planning phase, you come in as a new developer, you come into a new project potentially, you want to get an understanding of the code base. So that's where you can use Q Developer, you can ask it to give you an overview, to draw diagrams, to plan, for example, the implementation of a new feature. So it really helps you in this exploration phase and in the planning phase of building something new. Then, of course, you create, you code, and there's various approaches there. Some people use a test-driven approach, so they let Q Developer write tests first, and once they're happy with the tests that Q Developer wrote, they tell Q Developer to implement what those tests show. So it's a tool that you can shape to fit into your SDLC. Then, of course, nobody enjoys probably writing unit tests and setting up test frameworks and making sure that the tests themselves can run. So Q Developer is heavily used by my customers to write unit tests and to write integration tests as well. And the same with code reviews. What I've seen in the real world is that people will still require, of course, manual code reviews. So at least one or two people will review code, but you have an additional code reviewer in the form of Q Developer. And that's something that is more and more the case. It can also accelerate, and because maybe you don't want to wait for a second reviewer then, or in that case, a third reviewer. And also generate documentation is a big thing. Q Developer can draw, it can write READMEs, it can write multiple pages of documentation. It can be very precise there. As I mentioned, it's not only in the IDE. We have Q Developer plugins in VS Code, in all of the JetBrains IDEs, also in Eclipse, and also in Visual Studio itself for the .NET developers. But there's a Q Developer CLI, which is super popular, and people have been using it to automate workflows, things like shell scripting, bash scripting. The CLI is a very flexible tool that you can use across the SDLC. There's also an experimental feature, by the way, for the Q Developer CLI to run it as part of your CI/CD pipelines. Talking about CI/CD, we have integrations with both GitLab and GitHub. So you can interact with Q in your pull requests, in your issues as well. So you can essentially tag it and say, you review this or write tests for this, or write features in a pull request and change code there. You will find it in AWS documentation, in the AWS console, of course, for debugging. And we also have integrations in Slack and Teams. Okay, and so now I want to switch gears a little bit because we will see both Q and what I'm going to talk about right now. We'll have demos, and we don't want to spend too much time actually on the slides here. Q is, as I mentioned, in in the form of plugins in IDEs. And we've seen how agentic development came to QDeveloper as well. In the last, I don't know, 6 months to a year, more and more of these assistants became agentic, so they can do multi-step changes across multiple files. They can run commands, and they can really implement a whole chain of things. So they are very autonomous. They can really take on increasingly complex tasks. The way we see it is that you as a developer are always in the driving seat, right? So they will run commands for you, but commands that have specific weight, let's say, commands that can potentially delete or overwrite things, more dangerous commands, and they will always ask for permission. So there's autonomy. What we also see more and more is that your AI assistant is not only for an individual developer. So it started off that every developer would have their own AI assistant within their IDE, but we see more and more that people and teams want to share AI assistants and how they work, so across the full team. And what we also see, of course, is that the quality of AI assistants code goes up. But we see challenges, right? We see challenges, and if you have used AI assistants during coding, for example, that when they run into issues, they will really dig themselves into a hole, so they can't get back out of that hole, and they will try again and again with different approaches, but essentially they have a hard time keeping track of all of the steps that they have done. They have a hard time understanding complex systems. And so oftentimes we build prototypes with those AI assistants, but we then have a problem, and we struggle to move from a prototype to a production application. Now, what we then thought, and this actually came out of the idea to introduce test-driven development with AI assistants. We implemented and we came up with a concept called spec-driven development. So you can see here that what we have usually been calling vibe coding in the past is really this implementation step. So you're in the IDE and you interact through a chat interface with this AI assistant, and you're just making one change after another, and you really direct this AI assistant step by step. Spec-driven development zooms out of this, and it looks at multiple phases in the SDLC. So specs, so specifications, span from, of course, the planning and design, through the implementation, the testing and the QA, and the deployment. And because you have a spec that the AI assistant can rely on and can look back on, you can iterate between implementation and testing, and the AI assistant can autonomously iterate between implementation and testing based on this spec. And what we really found is that by using this approach is that the AI assistant is less, there's a smaller danger that it kind of runs into a wall and can't get back on track. And we'll see the demo how a spec looks like, and there's multiple specs that will work with. Okay, so what is the spec-based development? It's part of a new service, a new IDE that we have launched called Kiro, and it only launched in July, so about a month ago. And we see Kiro as this AI IDE that goes from prototype to production. So it's a very opinionated way of how to do engineering with an AI assistant. So it's more than just an assistant, it's really the whole IDE that is part of this. And before we jump into the demo, I just want to make one call out. On September 11th, we will run the AWS Summit in Zurich. And we will have a developer experience booth where we can essentially show both QDeveloper and Kiro. And if you haven't used Kiro before, if you're on the wait list for it currently, then join us there. You can interact with it. You can talk to us. We can talk about your situation and really compare tools. We'll also have a few sessions on both QDeveloper and Kiro and how to use QDeveloper, for example, in your DevOps process. Good. Then let's jump into demos. So I'm going to share actually Kiro. We'll start with Kiro. There we go. There we go. So what you see here is Kiro, and if it looks familiar, it's because Kiro is based on Code OSS, so it's essentially a VS Code fork. So lots of developers will be familiar with the interface, but there are a few differences, and we'll talk about all of them. The project that you'll see here is a used bicycle marketplace. So a used bicycle store where you can see the preview here. It shows various bicycles to buy. It's actually responsive, so it scales with the window size. There is an admin interface where we can actually see bicycles that have that were sold and stuff like that. So let me just go here. This is not deployed anywhere. It's just running really just locally here on my machine. And Kiro built all of this. So I haven't written a single line of code to build this, not one. And I want to talk about how the process looked like to go from 0 to this kind of application here. And if you look at this window here on the left-hand side, here, I'm looking to build an e-commerce website. This is exactly the prompt that I have started with and that I gave Kiro to build this. So it's not that I start with a single sentence and I can expect, that it builds a perfect application according to my needs. So I gave it quite a few bullet points, right? 4 bullet points here. And the website should be built with React and TypeScript. Postgres, SQLite, it's a prototype app, keep it very lightweight. And I told it that it should only implement a few happy path unit tests. Now, what Kiro then does is it creates, and you see it here on the left-hand side, it creates a spec that consists of 3 parts. And between every part here, so after it created the requirements spec, you can interact with it and you can change these requirements and you can ask for changes. And essentially, this writes a specification of the functional requirements of this application. So as a customer, I want to browse available bicycles to find bikes that interest me for purchase. It defines acceptance criteria. So none of these I have written myself. I made a few iterations to adjust them based on my needs, but Kiro really came up with this independently. So there are a few requirements that Kiro came up. I think it's 5 requirements here. And once you're happy with this, you jump over and you continue with the design. And again, Kiro then wrote this design spec. And the design is meant to be more technical, and it's less about the features and more about technical choices and architectural choices. So it talks about the different layers of the application, the different front-end components that it will integrate, that will be built, and the API endpoints, things like that, right? Again, if you're happy with that, you go ahead and it will create this task plan. So a list of tasks where you can see exactly what each task will do. And in this case here, it addresses requirements 1.1, 2.1, and so on. And what is really cool is that you can, for example, you click on implement this task, and then once it's done, you can inspect in a diff every change that it has done. So here this is task 1, and we can see how it implemented, for example, at the data model, right? So you have your types, your routes, so you can inspect everything that it has done. So in this example here, we have 6 tasks, and the sixth one here is currently not implemented. Only those first 5. And before we start task 6, I want to talk about a few other features. So let's say we are happy so far. We have a working application. This is running here in the terminal below. And let's say we want to not only use this spec-driven development, but also mix in a few vibe requests and do some vibe coding. So what I can do now is I can open this chat window here to the left, to the right. I can say I want to do vibe coding. And what I could do, for example, is on this page here, which is the bicycle detail page, I could add a little share button at the top. So I can say add a share button at the top right, let's say, of the bicycle detail. And you can see once I hit the hash here, you can add context. This is what we call a context modifier. You can add context in the form of either files or even the terminal, right? So you can say, use what is in the current terminal and solve the problem that is maybe there. In this case, I want to add a specific file, which is in this case called bicycle detail, the bicycle detail component that you see on the screen right now. And I want to say share a button at the top, add a share button at the top of the bicycle detail page. When you hit enter, it starts working, and you can follow along what exactly it does. We will talk in a minute about these steering documents that it mentions here. And right now, for example, when it starts working, you can see what it does to each file, and you can then view also the diff, right? So let's see what it does. Okay, looks better. So it ran into an issue, as you can see, but it fixed the issue autonomously. And you can see that we have now at the top right this share button here. So it gives me a summary of what it has done. And I can view the diff, so I can exactly see, what happened here. It removed something that was in the way or buggy, and I can look at each change it made. Now, I mentioned these steering documents here at the top. The steering documents, you can also see them on the left-hand side where it says Kiro Agent Steering Lessons Learned. These are files that will always be part of the context of Kiro. And if I open the one that I have here, let me close this, make a bit of space. This one I called Lessons Learned. When I implemented this application, I ran into a few issues, and Kiro made a few mistakes again and again. So I added this Lessons Learned file, and I actually told Kiro to add it. And I asked Kiro to write these lessons, and I'll go to this one at the bottom here. Something that happens in web development, you run npm run dev, so you run this dev server. Kiro ran it for me, of course, but then it ran into port issues because there was a dev server running, so it opens, it tries to open another port, or it runs into a port error. This happened again and again, so I asked Kiro to add it to this lessons learned file. And Kiro is quite smart in the sense that it not only writes the issue, but it also writes, essentially, it describes the patterns of when this happens, and describes a solution as well. So in this case, it says, run it in the background so you don't block the terminal as well, and so on. As a very quick example, we could do something similar for this share button, right? The share button is currently using a secondary caller of my CSS. So what I could do is I could, again, go to the chat and I can say, add a, and again, I'm going to use this lessons learned context modifier here. Add a lessons learned when creating new controls like buttons, always use primary color variants. And based on the context that Kiro has, from this CSS framework from Tailwind that we're using, it should be able to easily add a meaningful lesson here. Here UI component design, I just added this. Let me scroll there again, or let's view the div. And that's exactly what I want, right? I have the variant equals primary. If I now, let's say, remove everything in all the changes that it made to bicycle details, here we go, and this as well. And we can then say, okay, essentially the same task as before, add a share button. Then it will use this lesson in the lessons learned file, or it should at least, and it should add it in the primary colorway, which I think is something like bluish. Let me, and maybe this is right now messing up because I have this file still open. But that's the idea. Tobias will also talk a little bit about the agent hooks in a second. But here we go. Now this is now using a bit of a different colorway based on that lessons learned file that we saw before.
Another great thing that I experienced with these steering files, especially when you have like your own tech stack, let's say you do JavaScript and you use Bun instead of NPM, or you use Tofu instead of Terraform, you can also write steering documents that specify your exact tech stack and also versions, because obviously there is much more content in the internet regarding Terraform. So the LLM always tries to shift more towards using Terraform instead of Tofu, but there you can define it, and then Kiro is autonomously using the right technology.
So what I'll do now, I'll click on this read-write task. Essentially, I wanted to implement task 6, which is about tests. So it will add a test framework and then add tests. And in the meantime, while this is running, I'll hand it over to Tobias.
Okay, thanks a lot.
Good.
Let me quickly jump into my demo. Selecting the right window. Okay. Okay, so in our second demo, we are staying in Kiro, but now we are going to talk about MCP service. So what are MCP service? Traditionally, we interface with an LLM through a host or interface, be it Amazon Q, Kiro, Claude, ChatGPT, you name it. And this interface then sends prompts to an LLM that runs somewhere in the cloud. But this LLM itself, it doesn't have a mechanism to interact with the real world. It can't receive or write data from a database, or make API calls, or run an application on your computer, even though that would be very good if it could. So this is where MCP comes in, the Model Context Protocol, an open standard that is basically nothing else than a client-server protocol. So how does this work? We have an MCP host, in our case, Kiro or Amazon Q, where we configure the MCP service, and these MCP clients that get started then communicate with the MCP server. And the MCP server offers tools to the MCP host that the LLM decides on which tool to use for which task. We'll see that in a minute, and I hope it gets more clear. But basically, we send requests to, for example, server 1 for database, which is performing SQL queries, or we use something like a diagramming server, the one that I'm going to show you in just a second, or we have a more specified MCP server, in this case, the ECS MCP server, that does requests towards the AWS API. Yes. Okay. So how to get started with MCP service in Kiro? In here, you can see I have we have here a tab, MCP service. I have two MCP service configured, the one I just mentioned, the ECS and the diagramming server. And if I now open this up, you can see the list of tools that it's offering. So if I now hover over generate diagram, we can see we have this small window, and in here is the description of the tool. And this description is what the LLM is using for determining which tool to use. And also in this description is described what the LLM has to provide and in which structure to the server so it can do the request. Okay, so for this demo, I'm having here a project, an internal project from copebit Quest. It's a small game that we've developed for the AWS Summit in 2 weeks. So if you're there, please stop by our booth, play the game. You can win amazing prizes. And it was programmed not in Kiro, but by another person, by my colleague Jan. And he has some infrastructure files here, and I have no idea what's in there. I mean, I do know, but for this demo, I don't know. And traditionally, if I want to understand what this Terraform code does, I would have to read through all of them, or maybe make a small drawing, and but it would be very great if we could just throw this code at an AI to generate us a diagram. So for this, I'm opening the chat window again. Let me quickly copy my prompt. This is prepared, and I will send it off so we can discuss it very quickly. I'm asking Kiro to generate a new diagram of the infrastructure using the MCP server, the MCP tool, generate diagram from this server, analyze all the Terraform files, create a high-level AWS architecture diagram that shows the resources and their relationship. Don't be too comprehensive. So this is what Ramon has mentioned before, in a modern way of developing with AI. It's not just done by asking one small question. If I just ask it, write me a diagram, I get the diagram, but the quality differs every time. So with more information, for example, don't be too comprehensive, be high level, I get a more deterministic result. Now, if we go through here, we can see that Kiro has successfully read all the Terraform files. It used the list icons tool. This is very important. So it has all the AWS icons available when it calls the generate diagram tool. And we can see here that our diagram has been saved into the infrastructure folder. So let's have a quick look. Et voila. As you can see, we do have an AWS diagram with all the services that are described in these Terraform files. So the thing that Ramon just has mentioned, the other Kiro feature that I would like to show you is called hooks. So a hook is nothing else than an event trigger. You give it a title, a short description, you define the event that you want to subscribe to, in our case, files that were saved. You tell it on which path it should listen to the infra folder and all the Terraform files, and then it should rerun this, this prompt. So let me quickly go back into the infrastructure folder, and let's create a simple S3 bucket. I'm using Kiro here to generate an S3 bucket definition called, let's name it butterfly. They are very beautiful insects, so why not? Well, that looks about right. Let's accept. And when I now press save, you can see the hook gets triggered. And this is great if you want to automatically keep your documentation up to date or your diagrams. And this is all baked into Kiro. So one thing that we have to keep in mind here, because the LLM and the prompt, it's not deterministic. It's a bit like if you have 20 different developers and you give 20 different developers the task, draw me a diagram of this infrastructure, you will get 20 different results. So this is the same case here. Let me look. It's still working. So each iteration can look a bit different, but in my experience, the content itself is always very true. Not always in the same not as detailed every time, but yeah, as mentioned, if you give it to 20 different developers, you have 20 different results. So here we have the second diagram, where you can see we have less information about the networking compared to this one, but it still looks about right. We have Route 53, a load balancer, a certificate in front of it, and we can see here that we have our S3 bucket called Butterfly in here. Okay, so let me switch to the second demo. This is this one. Okay, and in here, as you can see, this is VS Code, because as Ramon has mentioned, Kiro is great. It's a very cool tool, but maybe you're just used to your IntelliJ or your VS Code or your Eclipse, and you want to stick with that, then that's all fine and fair. But you will ask yourself, how can I use these amazing features that we've just shown? So one way you can do this is by using Amazon Q. I have here another small project that I actually created with Kiro. Kiro is perfect for that. You just you go through the dialogue and through the requirements and then execute the task. And I asked Kiro to write me a small web app that looks like this. Very, very simple, small hello world, and some infrastructure code to run it on ECS. Now, I also did a small diagram here with the diagramming server. It's a very simple application, but I purposefully planted an error in there, which we now try to resolve using Amazon Q. As mentioned, the application is running on ECS, so I'm using the ECS MCP server, and this time I'm asking in the prompt, I have a cluster, it's called ECS MCP demo cluster, my tasks are failing, please find the root cause using the ECS troubleshooting tool from the AWS labs, so from this MCP server. I press enter, and now it's thinking, and it's thinking which requests it has to do towards the AWS API. And it's quite fast, but it's also very interesting to follow it, how it thinks this through. So he sees, okay, I do have the cluster exists, but 0 running tasks, 0 pending, 1 active service. Okay. I'm not going through all of it because it's quite fast. Here it has checked if something is wrong with the network. Okay, and it has found the root cause. It's very simple mistake actually, but it's very good for presentation. Of course, I do have an M1 MacBook, and the ECS task is running on Fargate, which requires that the image is built for x86. So we do have this architecture mismatch, and Amazon Q is also telling me how I can resolve this this error. The last thing I just want to mention, of course, this is a more simple error, but one thing I think is really cool and helped me when creating this demo is that when you have a code base like this, and like you have your JavaScript code, your Docker file, and something is failing on ECS, then I think you have to mute yourself quickly.
Sure.
Very loud. No problem. Then, and you run into errors in your log files, then the ECS MCP server is capable of reading those log files on ECS and then determining where the problem might be in your JavaScript code or in your Docker file or whatnot. So yes, these were my 2 short demos.
And Tobias, just a question from my side. This was only using the ECS MCP, right? Like you didn't have to use another one.
Yes, exactly. So there are a lot of specified MCP servers. ECS is one of them, and sometimes it also tries to use the AWS CLI, you know, because MSNQ has a very close relationship to the AWS CLI, of course. But yes, here I wanted to show off the ECS server in particular, because it has this really cool troubleshooting tool that goes into the logs and the whole tech stack to find the mistake. Yeah.
Nice.
Exactly. Is the task done on your side?
It's still, I mean, it implemented a lot of stuff. I see the tests are running. I can share what it has done so far.
Okay. Yeah, maybe quickly, and then we can.
Yeah, then we'll do the
questions.
So you can see Kiro, right?
Yes.
Yeah. So it's working and it's running tests. It's nice to see how it takes over the terminal and you can actually follow what it does in the terminal. So it implemented a bunch of unit tests and also tests using Playwright. And you can see in the changes here, all of the stuff that it has touched, you know. So the test setup, tests for the admin page, for the bicycle overview page, for the orders page. So all of this is happening, and you can follow it. You can activate this follow mode where you can see. Okay, now we see that there are 3 failed, 3 passed. So it's working. This is, you know, when we look at Kiro versus QDeveloper, you give it tasks through chat, and they're usually, you know, done in 1, 2, 3 minutes max. These implementation tasks that are part of the task list in Kiro, they're much more complex, right? So it's definitely, it's not rare that these will run for, you know, 10, 15 minutes, because they do address a lot of requirements at the same time. Yeah. Oh, okay. So here now, complete setup. It gives you a summary and everything. I think you wanted to do FAQ.
Summary is always really, really nice to really understand, because it really summarizes what it has done, and if something went down a path you didn't like, you can also correct it, right?
Yeah, and I mean, the summary is one thing. What is important then, when you have, let's say you implemented one of these tasks completely, and you want to continue with something else. You can then either work in the same context window, in the same chat window, or you say, let me rely on the spec as it was defined earlier, start a new chat window, and then rely on the definition of the spec there. So you have those 2 options. Either you give it the context of what just happened, you know, over the last few minutes, or you go and give it only the context of the existing specs.
Okay. So, are there any questions in the chat? Otherwise, I do have a question for you, Ramon. When should I use Kiro versus QDeveloper?
It really depends where you work. So if you work in an IDE, you know, let's say you're a Java developer, you work in JetBrains IDEs, and you're really you've invested a lot of time into customizing that IDE for you. Potentially, you work in a team where you need to use a specific IDE. then definitely QDeveloper is for you, because QDeveloper is essentially just a plugin and it works across IDEs. Also, I would say, don't forget QDeveloper CLI, which can be a tool that, I have customers that work 100% with the QDeveloper CLI, even though they work in VS Code, for example. If you're into, and if you're curious, and I would definitely say, try it out, but if you're curious to see how spec-based development works, use Kiro, give it a try, because of course you can do similar things, in, let's say, spec-based modes in QDeveloper. You can ask QDeveloper to write a spec, but Kiro is in that sense much more opinionated. So it will write a very well-defined spec immediately. So if you want to see how that works, if you're curious to see how, this fits into your software development lifecycle, give Kiro a try.
Okay. Yeah, also, you just mentioned the MSNQ CLI. It's a very great tool. I just used it a few minutes ago because I was trying to make an AMI from an EC2 instance. And what I didn't know, that first it takes a snapshot and then it creates the AMI from the snapshot. And if you just look at the AMI, then you wait because it's in a pending state. While in the snapshot window, you can see the status. So I asked MSNQ, is this normal? Why is it still pending? And because MSNQ, as this before mentioned, strong relationship with the AWS CLI, it used the AWS CLI, made the requests what's up in my infrastructure, and then it confirmed me that everything is going well, and we're at 62% with the snapshot. When the snapshot's done, the AMI is also available. So it's a very good, very great tool when you work with AWS. Yeah, we have one question in the chat. When is Kiro generally available and what will it cost?
So it's in preview right now, and I think we need to mention that the AWS service is in preview. We like to share services early. We want to get customer feedback early, but it's not a tool that we want you to use for production workloads right away. There's no GA date yet. We do know what it will cost. The pricing was recently announced, and I can share the link here. There we go. So you'll have a 14-day free trial to start with. And then you have 3 tiers between 20 and $200. And the difference between the tiers is essentially how many spec requests and how many vibe requests you will get per month. And what is a spec request? What is a vibe request? So the vibe requests are the ones where I've shown, you can just add a little feature, add a button here, do this, do that. So that is a vibe request. A spec request is every time essentially you click on a task implementation. So in my example, I had six tasks in this task list. Every time I click on it, and this thing will, as I mentioned, run for easily, 10, 15 or more minutes. This is one spec request.
Yeah, and they're more precious, right? Because they also always read the steering documents and all the content.
Yeah, they're much more complex. They run longer. They have more context. They need bigger context windows, and a lot of autonomy that is required there.
Okay. Yeah, perfect. Then I will quickly stop the recording.